Today I would like to take the opportunity to explain completing the square, the what, the how, and the why. So let's begin already. So what is completing the square? Completing the square is a technique for converting a quadratic polynomial of the form this trinomial ax squared plus bx plus c to the form of ax minus h squared plus k. And this is normally done to non-perfect square quadratic polynomials. But why? We need to do completing the square because we want to solve quadratic equations when factorization is difficult to perform. And we sometimes use it for graphing quadratic functions and also finding the coordinate of the turning point of a quadratic function. The normal trinomial that we use, y equal to ax squared plus bx plus c, give us the y-intercept in the value of the additive constant c. The sign of the leading coefficient a tells us if the curve is smiley face or the sad face. I will explain that afterward. Okay, this is when a is positive. When a is greater than 0, then we have the curve up, where it looks like it'll be a little bit like people smiling. But look at c here. C is where the curve cuts the y-axis. When x is equal to 0, then y is equal to c. So that's the first thing that we can see from a trinomial equation like this, from a trinomial function like this. Then c is quite useful for us to know some characteristic of the parabolic curve. And this is when a is negative. We can see the yellow line here looks like a frowning face. But why? Why do we need to perform completing the square? Okay, the reason being is that when we have it turned into this format, this is a perfect square component here. Look at my laser pointer. This is a perfect square, while k is another constant. This format will immediately tell us the turning point at coordinate hk. And the sign a tells us the curve is a smiling face or a sad face. So this is where the coordinate of the turning point, h and k. Look at it. Look at the h here. H is given inside this perfect square bracket here. So that is the coordinate of the. You can say that as the equation of the axis of the symmetry of the curve. Okay, and the k is the minimum value for y when the curve is a smiling face or a smiley face, while if the curve is a sad face, then the coordinate hk will give us the maximum point. So k is basically the maximum point y can achieve with this function. So that the red dot is the turning point, either a minimum point or a maximum point of a function. And then we can use the equation, the normal trinomial, to find the roots. Okay, for example, ax squared plus bx plus c equals 0 by means of factorization, so that we can solve a value for x. But factorization of some quadratic equation are not easily be performed. If you have done factorization, I think you know what I mean. And when we fail to factorize quadratic equations, we could almost surely find the roots if the quadratic equation is written as the completing the square, or as written as the perfect square plus a constant here, providing that the roots exist, of course. Now let's take a look at the basics of completing the square. Consider a monic quadratic equation with the form of this: x squared minus 4x plus c equals 0. And c is written in blue there because I will substitute that with some values for good illustration purposes. The first one, x squared minus 4x plus 4 equal to 0. Alright, this trinomial is a perfect square. We can write that to become like this, which is x minus 2 squared equal to 0. How do we get this? Okay, this equation is a perfect square if we know that discriminant is equal to 0. So what is discriminant? Let me just write the equation, the quadratic formula here. X is equal to minus b plus minus square root of b squared minus 4ac over 2a. Okay, apart from completing the square and factorization, we could also find roots by using this formula. This is what we call as quadratic formula. Okay, and the one that I want to highlight is the one in red bracket here. This is what we call as discriminant, and discriminant is normally written with a symbol D, capital D, b squared minus 4ac. So let's do a quick check here. What is the discriminant for this equation? So b is equal to 4 minus 4, sorry, let me just get that corrected, minus 4. A is equal to 1, that is the leading coefficient, and C, the constant, is 4. So discriminant is b squared. Oh, got it wrong here, sorry. That is minus 4. That is the linear multiplier, the linear coefficient. So minus 4, I write that as minus b again. Minus 4 squared minus minus 4, and then A is 1 and C is 4. So that equals to 16 minus 16 or equal to 0. So when we have discriminant to be equal to 0, then we're going to have the roots. Then we're going to have two equal roots, two equal real roots, or we can say that there is only one root for this equation. X minus 2 squared is equal to 0. That means x minus 2 is 0, and as such, x is equal to 2. Then we have found our root that we want by using factorization of a perfect square trinomial. Now let's take a look at the second case here. Have another value in place of c, which is minus 5. Well, this is not a perfect square trinomial, but we can still find the roots by doing factorization like this. And if we inspect the value of the discriminant, that is equal to 36. Okay, the discriminant itself is a perfect square. 36 is a 6 squared. Okay, and that's why factorization is possible to this equation. So if we take that, then once we are able to factorize it, then we know that x plus 1 is 0, or x minus 5 is equal to 0, because either one of these is 0, then the product of these two is going to become 0. So then we can find the roots by moving 1 to the right and minus 5 to the right. Then the roots are x equal to minus 1 or x equal to 5. So we can have found two distinct real roots. But let's take a look at the third case here. Okay, x squared minus 4x minus 7, and I have purposely written this in red. If we inspect the value of discriminant, then we found out that D is equal to 44, and this is not a perfect square. Alright, when the discriminant is not a perfect square, then it becomes almost impossible for us to factorize. The only way for us to find the roots of this equation is through usage of quadratic formula like this, or through completing the square, and that's the main reason why we do completing the square. So let's take a look at how we do this. So we have an equation like this, and we want to force it to become a perfect square. And how do we do that? We do that by modifying, by engineering the constant here, the additive constant here, to be to a certain value like this, okay, to be equal to the perfect square as in the first example here. So we have x squared minus 4x plus 4, but we cannot just put the number 4 to replace minus 7. We need to modify it by adding minus 11 here, because when 4 minus 11, that equals to minus 7. So the integrity of the equation is maintained. We just want to force this part of it, this part of the equation, to become a perfect square, and then we can turn it, we can factorize it to become perfect square, we move minus 11 to the right first, okay, then we can factorize it to become perfect square. Okay, this is where the magic happens. Then we take a square root of both sides, okay. On the right side, square root of 11 is plus and minus 11. Well, reason being is that whatever the value of square root of 11 is can be plus or minus. When a plus number is being squared or a minus number is being squared, then we'll get a positive value. So, using this technique, we can find that the roots very easily. Then x minus 2 is equal to plus minus 11. So the roots are either 2 plus square root of 11 or 2 minus square root of 11. So if we take our calculator to find the exact value, then it will be like this. X is equal to 5.317 or minus 1.317. And this is the very reason why factorization is not possible, because we have decimal numbers here. So how do we do completing the square then? Okay, as I said earlier, we will force the trinomial to become a component, to become a format that has a perfect square in it, when the original trinomial is not a perfect square. Okay, we will force it like that. And then we have introduced new constants, h and k here. And what is the value of k? What is the value of h and k? We can adjust that to become minus b over 2a for h, and then c minus b squared over 4a for c. Okay, how do I get this formula? We will cover that in future slides. But for now, let's try to take back the original example that we work on, which is x squared minus 4x minus 7 equal to 0. Okay, this is the trinomial equation that we cannot factorize just now. We wanted to force it to become this format, ax minus h squared minus k equal to 0. So what is h? Okay, I'm going to put it here. H is minus b over 2a. While, well, maybe I should put what are the value of a, b, and c. A is the leading constant. A is equal to 1. That is the coefficient of x squared there. B is equal to minus 4. That is the linear coefficient, the coefficient of x. And c is equal to minus 7. That is the additive constant. So h, according to this formula, is minus b, minus and minus b, minus, and then minus 4 here. B is the value of minus 4. And 2a is 1. So we will end up with a value of 2. Yeah? Minus and minus become plus. 4 divided by 2 is equal to 2. So h is equal to 2. And what about k? K is c minus b squared over 4a. So c is minus 7. Minus b squared. B squared is minus 4 squared. Okay, that is correct. Over 4 times a. So that is minus 7. Minus 16 over 4, which is equal to 4. So minus 7 minus 4, that is equal to minus 11. So by using this method, okay, we are able to change this trinomial to become a new form, which is a is equal to 1. Okay, that is the leading coefficient. X minus h. H is 2, so h x minus 2 then squared, plus k. K is minus 11. That is exactly the same as the one that we did before. Here. Here. Okay, up to here. Okay, this one multiplier here is not important, so x minus 2 squared is equal to 11, and as usual we take a square root of both sides, plus minus here. So now x minus 2 is equal to plus minus square root of 11, so x is equal to 2 plus square root of 11, or x is equal to 2 minus square root of 11. So we'll solve it. We'll solve finding the value of x from this equation using completing the square. Okay, we want to take another example. This time is not a monic, this is a non-monic trinomial. So this is the equation that we want to solve. 2x squared minus 8x minus 3 equal to 0. And again, the value of a is equal to 2. B is equal to minus 8. And C is equal to minus 3. And we're going to plug in the number to find the value of h. Let me just change the ink color so that you can see the difference. H is equal to minus B. B is minus 8 over 2 times A, which is 2. So that is equal to, okay, minus and minus have become plus. 8 over 4, that is equal to 2. So the value of h is 2. And next, the value of k. K is c minus b squared over 4a. So c is equal to minus 3 minus b squared, which is minus 8 squared over 4 times 2. 2 is the value of a. So that is equal to minus 3 minus 64 over 8. Okay, so 64 over 8 is equal to 8. Yeah, 8 squared is equal to 84. So minus 3 minus 8, which is minus 11. So we can now plug in these values, h and k, into this format. Yeah, a is equal to 2, so 2x minus h. H is 2 plus k. That means minus 11 equal to 0. So we move minus 11 to the right. That becomes, oh, I'm missing the square here. 2x minus 2 squared equal to 11. And transferring the 2, or divide the whole thing by 2, then we have x minus 2 squared equal to 11 over 2. And then we take the square root of both sides. Okay, and this is plus minus then. So x minus 2 is equal to plus minus square root of 11 over 2. And as such, we can find the value of x. We can solve the value for x in this equation to be x equal to 2 plus square root of 11 over 2, or x equal to 2 minus square root of 11 over 2. So we have solved the equation, the quadratic equation. Okay, one last example before we wrap up. Okay, 3x squared plus 9x plus 5 equals 0. So what's the value of a? A, the leading coefficient is 3. B, the linear coefficient is 9, and the additive constant is 5. Alright, so h is equal to minus 9 over 2 times 3, which is minus 9 over 6. Minus 9 over 6, or we can simplify it to become minus 3 over 2. Okay, and then k. K is c minus b squared over 4a. c is equal to 5 minus b squared. 9 squared over 4 times 3. That is equal to 5 minus 81 over 12. So 81 over 12 can be simplified. Yes, can be simplified to become 5 minus 27 over 4. And that is, well, we do cross multiplication. So that is 20 minus 27 over 4. That is finally equals to minus 7 over 4. Okay, now we are ready to transform it into this format, a perfect square format and a constant. Right. So a is 3, x minus h, minus and then minus 3 over 2, that is plus 3 over 2 squared, plus k, which is minus 7 over 4 equal to 0. Okay, we move minus 7 over 4 to the right, so that is 3x plus 3 over 2 squared equal to 7 over 4. And we want to move 3 also to the right, so that is now x plus 3 over 2 squared equal to 7 over 12. Okay, we took square root of both sides. This is plus minus now. x plus 3 over 2, that is equal to plus minus square root of 7 over 12. So now we, oh yeah, I think we can simplify this as well, yeah? Let me just backtrack a little bit. Let's do that simplification here. This is plus minus square root of 7 over 4 times 3, and square root of 4 is 2. So that means is, let me adjust this. That means is equal to 1 over 2 square root of 7 over 3. Yes, okay, that is correct. So now we can solve the value for x. X is equal to minus 3 over 2 plus 1 over 2 square root. Okay, let me just put a plus minus there, because I think I can factorize this 7 over 3. I will take out minus 1 over 2 and leave 3 plus minus square root of 7 over 3. So now I can write the value of x to be minus 1 over 2 bracket 3 plus square root of 7 over 3, or x equal to minus 1/2 3 minus square root of 7 over 3. So that we are done. We are done with finding out finding the roots for that equation. So how we can follow that? And let's talk about how did I get this formula, h equal to minus b over 2a and k is equal to c minus b squared over 4a. All right. This is where we'll prove it. Okay, we want to force this. We want to force this trinomial to become sum of perfect square and a constant. Okay, then let's start like this, yeah. That is equal to a. Just repeating that statement. All right, let's expand this square. So that is ax squared minus bx plus c, that is equal to a. Let me just make it a little bit nicer there, to be a little bit legible. So x squared, this is a binomial expansion. I hope you are fine with it. Minus 2hx plus h squared plus k. So then we multiply. We bring a to be multiplied there. So ax squared minus bx. Let's repeat this. To become ax squared minus 2ahx plus ah squared plus k. Okay, let's try to fix that bad handwriting things. Ah squared. Okay. And we are going to compare the like terms on the left and the right, and on the right of the equal sign. So let's compare this and this. Okay, those are the same thing. Let's not worry about that. And then the coefficient of x here and this. Okay. And lastly, C and this guy over here. This guy in blue are the additive constants. Okay, it doesn't have an x component in it. So then we can conclude that b is equal to, that is the coefficient of x. Compare that to the coefficient of x on the right side here. That is equal to minus 2ah. Okay. Let's omit the x there because we want to take the coefficient only. So I'm going to switch it over to the left, this one, and b over to the right, so that becomes 2ah equal to minus b. And divide both sides by 2a. So we're going to have h equal to minus b over 2a. So that is how I get the value for h here, and I have just proven my formula here. And let's take a look at the other one, the additive constant. Okay, C is equal to AH squared plus K. And we want to have K here, yeah? We want to have K. So K is equal to C minus AH squared. But remember, what H is. H is the expression that we've just got here. Then K is equal to C minus A and then minus B over 2A squared. Yeah. So K is C minus A. So now this is minus being squared, so it becomes positive, become plus, so B squared over 4A squared. And we can get rid of 1A here because we have common A. And strike the 2 there, become 1. So K is finally equal to C minus B squared over 4A. And this is where the proof comes in. So this is the formula, and the method, the how to use completing the square through 3 examples is what I think is the simplest way of doing completing the square. And I hope you find it useful. You can just memorize this formula and do completing the square more effectively. So I hope you find this video informative and helpful. So if you like it, please subscribe and like this video. Thank you very much. Bye-bye.